Lunar Node 1 is meant to be a demonstration of how we can use various navigation technologies to figure out where you are in and around the moon. My name is Evan Anzalone. I'm a navigation engineer at Marshall Space Flight Center, and I'm the principal investigator for the Lunar Node 1 Navigation Beacon Demonstrator payload. Some of the technologies here have begun as initial investment and technology developments when I first started here about 10 years ago. So it's been amazing to be able to see this technology grow from a paper study, software demonstration, all the way up to a payload that are actually going to be demonstrating technology from the lunar surface. Our focus is on developing the enabling technologies to help vehicles and the science payloads navigate on, know where they're at, and know what time it is on the moon. So part of our payload is demonstrate multiple approaches towards ranging, both through radiometric and also time-based delay measurements, in order to help vehicles understand how far away they are from some known location. That way they can help inform where they're at to guide their operations and navigate on the surface of the moon. I'm holding in my hands the Lunar Node 1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half U in size. You can see our external connectors here where we have our data and power to the lander itself. And within here, we have multiple boards that do the power regulation, our data control, our FPGAs, all those kind of electronics pieces are in here, as well as a small S-band radio that attaches up underneath this top radiator in order to distribute this heat and then to talk to the antenna, which mounts here. This is the same size and build as the flight payload. It's just not covered in MLI or some of the other materials that you'll see on the flight build itself.